Greetings to all. So we are in a continuity lecture session of data structures in R language. The topic for today's lecture is arrays in data structure. I recommend each and everyone before learning arrays in R language. So first you must learn matrix. So first you guys have to see the video of matrix, how to create a matrix. Then there is similarities between matrix and array. We will see um, the matrix definition and how to create, what is the function used for the array definition, what is the function for creating an array. Arrays are the data objects which allows us to store data in more than 2 dimensions. Coming to vector is a one-dimensional array. Matrix is a two-dimensional array. Here arrays in our language are multi-dimensional arrays. So R allows to create multi-dimensional arrays, and an array is created with the help of array function. The array function takes vector as input. So in vector takes sequence of values, so that is one-dimensional array. In matrix also takes vector as input. In arrays also takes what? Vector as input. And to create an array, it uses vector values in the DIM. DIM means dimensional parameters. So we will see the basic syntax of array function. This is the syntax of array function. Here you have to mention array name, and the function name is array. Here the data means the data is the first argument in the array function. It is an input vector which is given to the array. So basically the input vector means the vectors are two types. As I said in the first video of data structures, vectors are two types. The first one is atomic vector. It takes only same kind of data types in the array elements. So second one is generic vector, that is list. We will go to that, but in this case the matrix, vector and array all are dependent on atomic vector. So they will take only same kind of data. Okay. Matrices, number of matrices to generate data. Here matrices, the parameter matrices. Basically what array means, here we can create many number of matrices in array. For that reason I recommended you people to see the matrix video before learning arrays. And row size common, column size is common, dimension names is column as it is in the matrix. So we will see it in practical. I will opening my R environment for demonstration. For demonstration purpose. So how to create an array? So the first parameter is a vector. So I am taking a vector right now. The vector size, you can take whatever, but before mentioning the dimension is matrix dimension, right? If there are values of 9, so the dimension must be 3 into 3. Okay, if there is a 10 values in the vector, then the dimension must be 2 into 5 or 5 into 2. So take care of the dimension. So the syntax to create a vector, before that I'm creating a data variable. So in that I'm using range parameter 1 to 18, starting from 1 to 18. So dt contains 18 values. So dt is a vector according to the syntax of array. I am taking res, a variable, using arr array function. In the array function, the first parameter is data, right? So all the values are available in dt. So the next parameter in the array function is dimension. So I'm using the dimension dim is equal to combined function of. So I wanted to create a 3 by 3 matrix, and such kind of matrices I want two matrices of 3 by 3. Totally 3 into 3 9. I have how many values? 18 values. Then see how it will generate the output. You can see here. So by default, if we didn't mention what by row in the matrix, so automatically the values will be arranged in column manner, right? 1 2 3 4 5 6 7 8 9. And this is the first matrix. How many matrix I mentioned here? 2 matrices. So it generates 2 matrices. This is multi-dimensional array, right? So what array contains? Array contains many matrices inside it. So here you have to mention how many matrices you want. This is the first matrix and this is the second matrix. So, and one more thing we have is naming rows and columns, right? We can name rows and columns, not a lot of problem, as we have done in the matrices. So we can mention rows and columns. How many rows are there and how many columns are there means we have 3 rows and 3 columns in each and every matrix, right? So I'm creating C names here, C names, column names, column 1, column 2, column 3, and row names for row values, and using combined function row 1, row 2, row 3. So one more thing here the one more parameter I have is for rows and columns I have given names, but here you can see this is the second matrix and this is the first matrix. For these also I wanted to give names. So mat names combined matrix 1 comma matrix 2. Done. So I'm using array function right away here, dimension, so this one array dt dimension is equal to 3 comma 3 comma 2 comma, what is the variable? Dim names, right? In the matrix we have already used, and dim names parameter takes what? List as an input. List combines what? Vectors. So R names comma C names comma mat names. Done, right? So finally I need to close the array. So now you have to see the output here. So it was arranged beautifully, right? So it is something like meaningful compared to this previous output, right? Okay, this is the way to name your rows and columns. Here the important parameter for naming is DIM names, dimensional names, and one more important parameter to set dimensions and number of matrices is DIM, dimensions. So in array these two parameters are very much important along with a variable data. That data is nothing but what? Vector. Vector, that too what kind of vector is that? Atomic vector. Then finally how to access variables of this kind of array. This kind of array means here we are having what, two matrices in a single object. Two matrices in a single object. Generally we will access in a single dimensional array something called vector. In single dimensional array we can use index operator, right? In single dimension array we have only one dimension, so that we can use directly index numbers 0 or 1 or 2, right? In the matrices we have the combination of rows and columns, right? So there also we use the intersection of row comma column like this to access a value. Here the matrix name or array name is res, right? Res, we have res as a variable, and in this case I have two matrices. If I have mentioned row and column, it will get confused that from where it will fetch row and column. For suppose I mention 2 comma 2, so which matrix 2 comma 2 it will be accessed? This is a doubtful to the R environment. So for clarification we need one more dimension, that is matrix. So matrix number, this is clear, right? So here we will use matrix number. If you wanted to access 2 by 2 from matrix 1, you have to mention 1 here. So that means, see, row 2 column 2 of matrix 1, definitely what will be printed here? 5 will be printed. And row 2 column 2 of matrix 2, what will be printed here? 14 will be printed. So this is the way to access elements from array. So is there any possibility of manipulation of elements in the matrix? As definitely there is a possibility to manipulate elements in the matrix. Okay, so we have two matrices in a single array. So we can do multiplication, we can so okay, we try to create one more array. So vector 1 is equal to C of 1 comma 3 comma 5. Vector 2 is equal to C of 10 comma 11 comma 12 comma 13 comma 14 comma 15. This is another vector, but look at that, those two vectors are having varying sizes. The first vector size is different from the second vector size. Here I am creating a new vector using both, that is vector 1 comma vector 2. So both the values are combined and the result is stored in res1. So again I am using res1 and making it as an array res1 comma dimension. So what is the dimension parameter here? Dimension parameter, so very much is very important to mention number of rows and number of columns. These are the rows and columns, and number of vectors you need to create, right? So res1, this is the vector. So we have printed the vector, and this is the way to, this is one way of manipulation of having vectors of different sizes. And I am taking one more vector 1 combine function of 847 vector 2 combine function. Here I am using what, 16 comma 17 comma 48 comma 40 comma 36 comma 73. This is also different sizes. So here also I am taking another variable res2. Here I am using array function again, array function. So directly here I am combining both vec1 comma vec2 comma dimension is equal to combine function of 3 comma 3 comma 2. So print res2, right? And then we will create matrices from these arrays. Let us think. mat1 res1 of. So if I'm left, actually what is there, row comma column comma matrix number, right? In this place, if I left this thing, so I want all rows, I want all columns of matrix 2. So next mat2 res2 of all rows, all columns of matrix 2. I will print mat1, this is the matrix 1, mat2 is matrix 2. So I will add these matrices. So what, matrix 1 plus matrix 2, right? I will print result 3, right? So 1 plus 8 9, 3 plus 4 7, right? Addition is possible. Here what I have taken from the matrix 2 all rows and all columns, from the matrix 2 of result of matrix second matrix result 2. So I have created matrix addition, and you can perform calculation across array elements using apply function. So apply function, this is important. Apply function is we are not discussed the apply function in matrices, so we will discuss it in arrays. So if you have a data in the form of an array or matrix and you want to summarize this data, summarization is possible in matrix or array using apply function. So if you want to summarize this data, R allows apply function. The apply function traverses an array of matrix by column or row and applies a summarizing function. The syntax of apply function is look like this. We will see the syntax of apply function here. Apply and data that we need to perform summarization and margin. Here the margin is having two values, either G1 or 2. The 1 is for row, 2 is for column. That means if I wanted to traverse the matrix in row manner, then I will choose 1 in the place of margin. And if I wanted to traverse the matrix or an array in column manner, so I will place 2 in the place of margin. Then I will apply summarization function like what sum, mean, median, mode, whatnot. I will use the summarization function here. So function here, what data is array or matrix, and what margin is margin is traversing row wise is 1, column wise 2, and the finally function is summarization function, and like sum or mean or mode or median, whatnot. This is the function. So we will apply this in our program. So for this I will create an array. I will create an array, variable a, combine function 1, 3, 5, vector b 10, 11, 12, 13, 14, 15. Two vectors I have. So I'm taking new array, new array. In this new array, I will use array function. First parameter is combination of a comma b, right? And dimension that I wanted to use, dimension is equal to how many rows and columns you want. I want 3, 3, and I want 2 matrices using those values. This is the, so in unexpected comma in new ARR, where unexpected, yes, dimension is equal to not unexpected. That is a wrong statement, but I forgot to mention combine function here. That is the error that is supposed to show us. Yes, new ARR. So this is the output of new array, it is having 3 by 3 matrix, and it generates 3 by 3 of two matrices, right? So now what I will do is I will apply um, a function called apply on new array, right? So see the result. I'm applying apply function. Apply, what is the first parameter? Data, that we need to perform summarization functions. So the data is available in new arr variable, right? That is an array. And so here I wanted to perform, or I wanted to traverse in row manner. So for that, for row, what I have to use? 1. We should give this number in combine function. So it will become a vector, right? Then I want to apply summarization function sum. Okay, right? Yes, done. See result. What is the result? 48, 56, 64. So I will explain how it came. So see that what is the margin number we have used here? 1, right? So it will traverse in row manner. So 1 plus 10, 11, 11 plus 13, what? 24, right? Here 24, row sum 24, 24 plus 24, first row 48. Then after second row sum 3 plus 11, 14, 14 plus 14, what? 28, 28 plus 28, 56. Likewise it will use summarization on array or matrix. You can apply this function in matrix also, that is not at all a problem. So finally we have completed with the concept of arrays. At the end of this arrays lecture, I wanted to tell you the differences between vector, matrix, and array. Okay, so array is basically vector is one dimensional array, whereas here matrix is two dimensional. And this is multi-dimensional. Okay, and the common factor in these, all of these, is they need what? They need the support of atomic vector. So all the values will be atomic vector values will be supplied as input to vector, matrix, and array. This is the only difference between vector, matrix, and array, and all these are atomic vectors of different dimensions. So this is all about the arrays class. Thank you.